We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard.
Houston, Tranquility Base here. The Eagle has landed.
Roger, Tranquility. We copy you on the ground. You got a bunch of guys about to turn blue.
That's one small step for man, one giant leap for mankind.
The push for man to enter space and walk on the moon signified an end to the modern era and a beginning of a postmodern era or space age. The prospect of living in a habitat like outer space or the surface of the moon posed incredible design and engineering challenges. Space engineers and designers turned to the principles taught in the international style of architecture to solve many early problems from manned spaceflight. Man's ability to travel to and inhabit extraterrestrial places has been made possible by the lessons learned from modern design techniques and practices. The way that these vehicles and habitats for extraterrestrial life are constructed, in turn, influence the way that architecture is designed on Earth.
Space, the final frontier.
Space can be considered a frontier, a place on the boundary of settled land and the unknown. These types of habitats pose great dangers to those who can choose to inhabit them. Quote, assuming comfort for all occupants, environmental conditions drive architectural design. This quote from A. Scott Howe from the article titled Architecture from Other Planets highlights the importance of the environment in determining the limitations and constraints for designing extraterrestrial habitats. The harsh environment on the moon and Mars and in space dictate the needs of the design.
Skylab starts in the dreams of the people who wanted to go into space for a long time, early in the 20th century. We saw people who were thinking about how do we get humanity off the planet Earth.
While NASA was developing Skylab in the 1970s and subsequently the ISS in the 1980s, they released a document titled Space Station Reference Configuration, where they outlined modernist sensibilities to be utilized in the designs for their extraterrestrial habitats. Quote, the requirement that the manned space station become a permanent facility implies that, in addition to growth capability, it must also possess the characteristic of being able to incorporate advances in technology as they occur. This compatibility with modernization or technology transparency is then considered a significant design driver. End quote. This quote calls on these early space station designers to utilize the modernist ideas of modularity, adaptability, replicability, and technological transparency. These tenets of modern architecture and design allow the space station to become a reality in the late 20th century. Because of these early designers' devotion to modularity and adaptability, the International Space Station, which is currently the only inhabitable piece of extraterrestrial architecture, has survived for over a quarter of a century and has been worked on and inhabited by people from 19 different nations. The ISS took many years to complete because of the difficulty of bringing pieces to space. The space shuttle program brought both astronauts and space station parts to be added to the existing structure. These diagrams and videos show off the modular nature of the ISS. While the station was considered fully built in 2011, experiments continue to be done with the station on new types of astro-architecture techniques and materials. Architect and Professor Xavier de Calester gave a TED Talk in 2016 where he outlined his conceptual designs for the potential Martian habitats. Cargo space, cargo weight, atmospheric conditions, astronaut safety are all important design constraints that Xavier and his team had to work with. Here he outlined his proposed solution.
We're going to go and use local materials. Now, local materials is something we do on Earth as well. Wherever we build, whatever country we build, we always look at what are the local materials here. Problem with the moon is, what are the local materials? Well, there's not that many. Well, actually, we have one. It's moon dust, or fancier scientific name, regolith, moon regolith. Great thing is it's everywhere, right? The surface is covered with it. It's about 20 centimeters up to a few meters everywhere. But how are we going to build with it? Well, we're going to use a 3D printer. Whenever I ask any of you...
By utilizing this 3D printing idea, a structure could be made partially from recycled regolith and partially from structures brought from Earth. This efficiency, economy of resources, and technological transparency is another example of modernist sentiments making their way into the design philosophies of Astro-Architecture. These are the ways of building and designing that seemed futuristic in the early 20th century, and they continue to influence great design today. It is easy to notice how influences of modernity crept into the environment of Astro-Architecture. The harsh environments and large amounts of energy and money required to send things off Earth influence the way that these structures are designed. Modularity, technological transparency, and efficiency are what work in space and on other planets. The structures created for human inhabitation of space are testaments to the brilliance of modern sensibilities.